Today we're going to take notes on rectangles. The sub should have given you notes on rectangles, and you will need those. Plus, last class we started a study guide, and at the top of the page we talked about parallelograms. We're going to add on the bottom of the page rectangles. So you need to pause the video, find your study guide that has parallelograms on so you're ready to add rectangles, and then get your notes on rectangles ready so that you're ready to go with the video. Remember though, as you're watching the video, I may be talking a little bit faster than I would in class, but it's a video. Pause it at any point you need to keep up with the notes. On your study guide, parallelograms were at the top of the study guide that we did last class. At the bottom of the study guide, we're going to add in rectangles. Okay, we'll do the back next class. So a rectangle is a parallelogram with 4 congruent angles. A parallelogram with 4 congruent angles. So we're going to narrow down the topic of parallelograms a little bit more specific and look at a little more in detail. So we'll look at specific types of parallelograms. Okay? So all the angles are congruent. Well, we know that in a quadrilateral, all the angles add to 360. And if all the angles are the same, then I can do 360 divided by 4, and that's going to get it so that all 4 corners are 90 degrees in a rectangle. That's the definition. As far as the properties are concerned, the first one is that the diagonals are congruent. So because it's a parallelogram, they bisect each other, but now we know they're congruent. So when we draw in the diagonals, not only do they cut each other in half, but because they were the same size to start with, all 4 of these are now going to be equal in a triangle, or in the rectangle. Now, as you can see, when we draw on the diagonals, it creates 4 triangles. Those 4 triangles each have 2 sides congruent. A triangle that's got 2 sides congruent is called an isosceles triangle. We studied them first semester. And if you remember an isosceles triangle, the 2 sides that were congruent were called the legs. The third side was called the base. And the 2 angles that touched the base were the base angles. If you remember, in an isosceles triangle, the base angles were always congruent. That's going to happen again in this rectangle. We'll get to some examples of that in just a minute. The other thing that we're going to write for properties is all the properties of a parallelogram. So everything that we learned last class also applies to a rectangle. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive sides are supplementary, and diagonals bisect each other. All of that applies to a rectangle. Those are all listed on the top of your worksheet, so you should be okay. All right, now put that to the side and take out the notes that the sub gave you today about rectangles, and we're going to try some examples. Okay? We're going to fill in the blanks using this picture of a rectangle. Now you're going to have to remember some notation stuff from first semester in order to do this correctly. When it puts this little m in front of it, this means the measure, which means they're looking for a number. Another hint that they're looking for a number is there's an equal sign. So it wants to know the measure of angle MAR. Well, let's see if we can find MAR. M to A to R would be this angle. In a rectangle, what do we know about the corners? Well, we know they're right angles, and a right angle is always 90 degrees. This question, their second blank, this with the bar over it wants to put the name. So when they have a congruent sign, that's another sign they want the name. They're looking for letters. MA, which is the top segment, is congruent to which other segment? Well, that would be KR. If you put RK, that's the same thing. What else do we know? AR, the right, is congruent to what else? Well, it's a parallelogram, so it's congruent to the left. MK. MR. Well, MR is this entire diagonal here. Well, MR is congruent to the other diagonal, which would be AK, or KA, whatever you want to write. Okay, KS, which is this segment of the diagonal, is congruent to 3 things. Well, it's congruent to this part, SR. It's congruent to this one, AS, and it's also congruent over here to MS. All right, let's look at the next example. We're going to fill in some missing angle measures. Well, we got to think about what we know about a rectangle. We know in a rectangle, the four corners are 90 degrees. So if we do 90 minus 26, well, what do we get? 90 minus 26 gives us 64, so angle 1 is 64. It's a parallelogram, so things that we learned about parallelograms are also true. 26 and angle 9 are alternate interior. They match. 1 and 8 are alternate interior. They match, so that's 64. But to go any further, we have to remember the one thing that we talked about. We have isosceles triangles because in a rectangle, all four of these are equal. In an isosceles triangle, when you have the two legs congruent, the two angles that touch the base are going to be equal. So if I look at that top triangle, 26 and 5 are base angles. That means 5's got to be 26. 5 and 6 add to 90, so 90 minus 26 is 64. 6 and 8, they're base angles. Oh, look, we already have that right. They're matching. 9 and 11, they're base angles. So that means 11 is going to be 26. 90 minus 26 is 64. 64 and 2, oh, they're base angles. They match as well. Now we're just left with the three angles in the middle. So let's start with angle 4. If you look at the top angle, we know 26, 26, and then the missing angle. So we know all the angles in a triangle add to 180. So if we do 180 minus 26 minus 26, let's see what we get. 180 minus 26 minus 26 is 128. So now we know that angle 4 is 128. That means by vertical angles, 10 is 128. And you can see the angles match, so that makes sense. Now to get 3 and 7, you've got two choices. You've got the triangles on the right and the left, which these three angles would add to 180. Or you know that 3 and 4 are a linear pair. So however you do it, I'm going to do the linear pair one. So I'm going to do 180 minus 128, and that gives me 52. So 3 is 52, and 7 is 52. Okay, I want you to pause the video at this point, and I want you to try and do example 2 on your own. Even if you can't get all the angles, take a moment and see if you can figure any of them out and start to go over the process. Okay, let's see what you're able to get for example 2. Well, in example 2, they started with this angle being 53. So because the corners are 90, you could figure out that 6 was 37. You could also do 2 and 11 because of alternate interior angles if you wanted to, but you didn't need to because you know at the top 5 and 6 have to be base angles, so they're congruent. So 5 is 37. 1 and 5 add to 90, so 1 is 53. 1 and 2 are base angles, so 2 is 53. 2 and 11 add to 90, so 11 is 37. 11 and 9 are base angles. They're congruent. 8 and 9, they add to 90, so 8 is 53. And going back, 53 and 8, they're base angles. Okay, then I wanted to find the angle 4 in the middle, so I did a triangle. 180 minus 37 minus 37 gave me 106. I knew 10 had to be 106 as well. You could do the same thing with triangle with angles 1, 2, and 3. They all have to add to 180 to get 74. Or you could say that 3 and 4 were a linear pair, and you get 74 for the other two. Okay, we'll come back and try that again. Starting to get the hang of it a little bit. All right, let's look at example 3. We need to fill in the blanks. Now right here, it's got an equal sign and there's no bar. That means they're looking for the measure and they want you to write a number. So let's see, DC is this segment down here. Well, because the rectangle is a parallelogram, it's got to be congruent to the opposite side. So DC is 6. BC is this segment over here. Well, it's got to be congruent to the opposite side, so BC is 8. EB. Well, in the picture, we know this part right here is 10. So because it's a rectangle, all four of these are going to be the same. So EB also has to be 10. DB, well, that's the whole diagonal, so that would be 10 plus 10, which would be 20. AE, well, it's another part of the diagonal. It's going to be 10 because all the parts are the same. AE is 10. EC is 10. So AC, the whole thing, has to be, oops, I got off one and I got drawn in the picture, not on mine. It's 10. So AC is the entire crazy, sorry. AC is the whole diagonal, 10 plus 10, which is 20. All right, let's look at another example. Example 4, they want us to find the value of x and y. Well, x is an angle measure. We know that because there's a degree symbol. And because it's a rectangle, all four corners of a rectangle are 90. So that means that 6x equals 90. So we're going to divide by 6. 90 divided by 6 gives you 15. So x is 15. Now we need to find y. Y is on sides. A rectangle is a parallelogram, so opposite sides are congruent. That means 5y minus 16 equals 3y. So I'll subtract 5y from both sides, so I get negative 16 equals negative 2y. When we divide by negative 2, y equals positive 8. Next example. We want to find the value of x and then find some other angle measures. And the part that makes this tricky is writing it on the picture and figuring out the angle. Once you know that, you're home free. First it says the measure of ABD. So let's find that one. I go from A to B to D. That's this angle. Is 2x plus 20. Then we say CBD. From C to B to D. That's this angle here. Is 3x plus 15. So if I'm looking at the picture, if it was a parallelogram, there was nothing I can do. But because it's a rectangle, we know that all four corners are 90. That means that these two angles together must equal 90. So I'm going to say 3x plus 15 plus 2x plus 20 equals 90. Okay, combine like terms, so I get 5x, plus 35 equals 90. So I'm going to subtract 35 from both sides. So I get 5x equals 55. I divide by 5, so x is 11. Now it wants to find the measure of ABD. Well, ABD was our yellow one. We can do that. We'll just plug it in. So that's going to be 2 times 11 plus 20. 22 plus 11 would be 42. Now it wants ABD. That was our green one. Plug it in again. We'll take 3 times 11 and add 15. So we have 33 plus 15, which would give us 48. Next one, example 6. We want to find x and we want to find AB. If this had been a parallelogram, there would have been nothing we've been able to do. But because it's a rectangle, we know that all four of these segments are equal. So it doesn't matter which two they give us, they're equal. And just like with a parallelogram, if they give you sides, your only option is equal. So that means that 3x minus 12 has to equal x plus 10. So to solve, we're going to subtract x from both sides. So we get 2x minus 12 equals 10. Add 12 to both sides, so we get 2x equals 22. So x is 11 when we divide by 2. Now it wants us to find AB. Well, AB is this whole segment. We only know part of it, but that's okay. This is 11 plus 10, so this part here is 21. But we know this bottom left has got to be equal to the top right. So this over here is 21 as well. So AB is going to be 21 plus 21, which would give us 42. Example 7, we want to find x and y. Okay, x, well, it's an angle measure because it's got a degree symbol. All the corners have to equal 90 in a rectangle, so that way we know that 6x equals 90. So when we divide by 6, x is 15. Y, well, y is a side, and these are opposite sides. Opposite sides are always equal, and anytime we have a side, the only option is equal. So we have 6y minus 14 equals 3y plus 10. Alright, so I'm going to subtract 3y from both sides, giving me 3y minus 14 equals 10. Add 14 to both sides, so we get 3y equals 24. We divide by 3, so y comes out to be 8. Okay, but this is asking for more information. There's no bar and there's an equal sign, so they want the measure or they want a number for the length of AC. Well, AC is this one over here, so I'm going to plug it in. So I'm going to take 6 times my y, which is 8, minus 14. Well, that's going to be 48 minus 14, which would be 34. Now they want BD. That's the right side. Well, I could plug it in, but if the left side is 34, the right side has to be 34 because opposite sides are congruent. Okay, I'd like you to pause the video for a second and then try example 8 on your own. Okay, example 8. We've got diagonals, and remember the 4 segments of a diagonal are equal. So that means 4x minus 6 has got to equal x plus 9. Okay, so that's what I did in red, so x comes out to be 5. Then I'm going to plug it in. MR, we know, is 14. RH, it wasn't given to us, but all 4 of those segments are equal, so it's 14 as well. TA is the whole diagonal, so we know it's 14 plus 14. That's how we got this to be 28. Okay, and over here, when they write the M, they want the measure. Oops, can't write. Let's make it M. Measure, which means they want a number, and the corners of a rectangle are all 90. Okay, one last problem, example 9. I want you to pause the video and try that one on your own. On that one is another one where we're finding the angle measures in a rectangle. We did 2 examples earlier in your notes, so look back on that if you're stuck. But see again, really pause it and try some on your own and see if you can come up with any of those angle measures on your own first before you listen to the video. Okay, this is what you should get. Because the corners of a rectangle are 90, you could do 90 minus 31, and that would give you 59. Okay? Then, because it's an isosceles triangle, because you create 4 isosceles triangles, 1 and 2 are base angles, so they're going to be congruent. 5 and 6, they're base angles, they're going to be congruent. 8 and 9, they're base angles, they're going to be congruent. 11 and 31, they're base angles, they're going to be congruent. Then finding the inside one, you got a triangle. 180 minus 31 minus 31 is how I got the 118 in here in the middle. 3 and 4 are a linear pair, so I subtract it from 180, and 3 is 62. Okay, next class, I will be checking to see that your notes are complete. I will also be giving you points and checking to see if your homework is complete, so make sure that you have both of them done by the time you come to class next time.